So today we're going to learn about radicals. So first we're going to start with a radical review. So these are the things that you should already know, but just in case you didn't learn them or you forgot them, I'm going to teach them to you now. So the first thing is adding radicals. So we can only add radicals if we have the same thing underneath the radical. So it's kind of like having like terms. So for number 1, we have a 3 under the radical and a 12 under the radical. So right now, we can't add them. This would be where we'd have to stop. But if you remember, we can simplify radicals. So let's look at simplifying square root of 12. So if you remember at the beginning of the year, we did this by using factor trees. So what are 2 factors of 12? We have 3 and 4. Now if you get a number that's prime, circle it. We're only going to circle the primes. 4 we can break down again. So 4 we can break down to 2 and 2. 2 is a prime, 2 is a prime. So that's as far as we can go because we can't break down 3, we can't break down 2, or this 2. So square root of 12, we can reduce that to whatever we have pairs of is going to go on the outside and we only write it once. So how many pairs of 2 do we have? We have 1 pair of 2, right? So we're going to write 2 once on the outside. And that entire pair goes away. So you'd only write the number outside for each pair that you have. We only have 1 pair, so we only write 2 ones. And then whatever we have left over, we put on the inside. So we have 3 left over. So square root of 12 is the same thing as 2 square root of 3. So let's replace that in our equation. So we have square root of 3, and now we have 2 square root of 3. So now we have the same thing under the radical. They both have 3's. Now we can add. So when adding radicals, if you have the same number underneath the radical, you add what's in front. So here, we can say there's an understood 1 in front of this square root of 3. So we're going to add the 1 plus the 2. What is 1 plus 2? 3. So we'll have 3, and then we keep the radicals the same. So we'll have 3 square root of 3. And that'll be our answer. Let's look at number 2. The same rules go with subtracting radicals, so we have to have the same thing underneath. So let's do a factor tree for 75. What are some factors of 75? We have 5 and 15. Are either one of those prime? Yes, 5. But we can break down 15. So 15 is 3 and 5. 3 is a prime, 5 is a prime. Do we have any pairs? Yes, we have 1 pair of 5's. So 5 goes on the outside. Cross out the entire pair, and what do we have left over? 3. Now let's try and see if we can break down 27. What are 2 factors of 27? We have 9 and 3. 3 is a prime. Can we break down 9? Yes, 9 is the same thing as 3 and 3. Do we have any pairs? Yes, we have 1 pair of 3, so we write 3 once, and we only cross out the pair, so we can only cross out 2 3's. Now, do we have anything left over? Yes, we still have that 1 3 left over. So the square root of 27 is the same thing as 3 square root of 3. So let's replace that. So we'll have 5 square root of 3 minus 3 square root of 3. So it's just like having like terms. So what is 5 minus 3? We'll only subtract the numbers in front of the radicals. And it's 2. So we'll get 2, and we leave the square root of 3 alone. So this is our answer. Now with multiplying radicals, we multiply what's underneath the square root. So here we have 6 and 2. What is 6 times 2? It's 12, right? Now does 12 break down? Can we reduce the square root of 12? We just did it in problem number 1, but just to show you again, we'll draw the factor tree. Factors of 12 are 4 and 3. Doesn't matter what factors you choose. You could have used 6 and 2. It would have been perfectly fine. 3 is a prime, and 4 is 2 times 2. So we have one pair of 2's, cross out that pair, and 3 is left over. So 2 square root of 3 is our answer.